Let's see quickly what chapter are you seeing. Chapter 2? Okay, fantastic. Thank you very much. All right. Now, if you see, it all started with Toyota. Okay, it all started with Toyota and company Motorola, which actually formed this DMAC methodology. Earlier, it was MAIC methodology. All of you type MAIC in the chat box. Okay, measure, analyze, improve, and control. Okay, measure, analyze, improve, and control. Then General Electric actually added D, defined to it, and now it is called as DMAC, DMAIC. You can type DMAIC now. Okay, all right, fantastic. And Motorola conceptualized this concept of variation reduction program. Okay, all of you type VRP in the chat box. Variation reduction program, VRP. Okay, and variation in statistical term, it's called sigma squared. It's called sigma squared, and square root of variation is actually sigma, which is standard deviation. Okay, square root of variation is actually sigma, which is standard deviation. If this is clear, all of you give me a thumbs up. Okay, and that is why it is called as Six Sigma, because as you reduce the variation to a particular level, you might be at many levels. You might be at 1 sigma level, 2 sigma level. You are going to reduce the variation. Now, Toyota conceptualize what is called as waste elimination. Okay, all of you type WE in the chat box. We, okay, waste elimination. Okay, now we are is the power. We and we are the power. We means waste elimination and VR means variation reduction. We and we are the power. So we means waste elimination, VR means variation reduction, and that's the power. Okay, how many of you are excited? Yeah, we are the power. So while the roots of Six Sigma are commonly attributed to companies like Toyota and Motorola, this methodology is grounded into the concepts that dates back as 19th century. So this is not something that is invented new. Okay. So how many of you know total quality management? Type TQM in the chat box if you know about total quality management. Type TQM in the chat box. Okay, there are Dinesh Kumar knows about TQM, Rajiv knows about TQM, Dhirendra knows about TQM. Fantastic. Now TQM, modern quality and improvement programs, has the roots in TQM, but here ultimately it is reducing errors, defects, making the process more efficient, improving customer satisfaction, boosting profits. Quality programs, if you see, okay, they look for some specific goals sometimes. Okay, most of the times quality programs are directed towards achieving a specific program. So the program keeps going without stopping, always aiming for the same thing or reaches the goal and then starts again. So project by project approach. Okay, all of you type P by P in the chat box. Project by project approach, one project after the other. Six Sigma is instilled the culture of continuous improvement in the organization. Okay, the culture is very, very important. Small and sweeping improvements. Thank you very much for the active participation. Please continue to participate whenever I request you to do so. And Six Sigma does work towards individual goals with regard to each projects. And projects are the part of the overall culture of improvement of an organization. So after the projects are concerned, Six Sigma puts a control method in place. That is why in the DMAC methodology, DMAIC, the last one, control method, is for sustaining. Because you go to the fitness, you do all the workout, you do all the diet control, change your routines and all that. You do all the workout, diet control, within 1 month you reduce the weight. But if you don't sustain it, if you don't put control measures in place, what will happen? Go back to square one. Same thing can happen with Six Sigma. You do the project, and if you don't put proper controls, you go back to original levels. Right? How many of you can relate to what I'm saying? Type ICR. I can relate in the chat box. Great. So many of you can relate. Radhakrishnan, Mohsin, Surya Narayanan, Uttam. Uttamandre, Sibyl, my God, so many people can relate to what I'm saying. Great. Fantastic. Okay. All right. So let's quickly ask this question. What distinguishes Six Sigma from other traditional quality programs? Six Sigma roots dating back to 19th century. Six Sigma focus on achieving specific goals. Six Sigma concerned with continuous improvements, right? And quality culture. Six Sigma is short-term goals with fixed goals, right? Short-term program with fixed goals. So what is your best answer? Let's see. What is your best answer? All right, so that's a C. So those who have typed C, please send pizzas, burgers, chocolates for the right answer. Okay, that's the right answer. Fantastic. So let's move to the next level. Good, good, good. Now, if you let us see the development of statistical process control. Okay, all of you type SPC in the chat box, the development of statistical process control, and let's quickly dive into that. So we apply statistics across all the define, measure, analyze, and verify control properties, right? So Six Sigma teams, what they do is, thank you very much for your active participation. So they use DMAC methodology or a DMA-DV methodology. Okay, all of you type DMA-DV also to accomplish this. So what is this DMA-DV? It is define, measure, analyze, design, and vary, which is actually a part of higher level, like Six Sigma at a product development stage itself. Okay, at the design stage itself, DMA, DB. Fantastic. If you want to know about DMA, DB and all that, join this upcoming webinar in my link and I'll share with you the details. Okay. We will discuss about this later. Okay. Now, there was this person called as Gauss, okay, who actually was a backbone of all the Six Sigma methods. Okay. And he had done what is called as, he has discovered a distribution which is widely used now. So all of you type GD in the chat box. It's called Gaussian distribution. You can also type ND in the chat box for normal distribution, which is a bell-shaped curve. You can type BSC. Okay, BSC is bell-shaped curve. Okay, so we know today as normal curve. Okay, which is used in most of the probabilistic models. We'll be using this quite commonly. This is perhaps widely used. Okay, fine. Now, okay, a quick question. How many of you can identify this person? Let me see if somebody can identify this person. I've shown this person during my last webinar also. Some of you are joking. They're saying it is you. Okay, it's called Walter Sheward. All of you type WS in the chat box. Okay, so his contributions are many. But then if you ask one question, who is the father of control charts? Who is the father of control charts? You should say Sheward. Okay, so you can relate him closely to as the father of control charts, who started this concept of sigma level. You can relate to him. All right. F4CC says Dinesh Kumar. Fantastic. All right. Now, if you see at different sigma levels, 3.4 sigma is called as a Six Sigma. We have seen in last session. And if you see, we have seen one amazing example in the last chapter. What I want to share with you is, I want you to observe only this, okay? If you see the total cost, which is in the last column, which is only $4,000, $4K at Six Sigma, when the variation increases and the sigma level decreases by 1, the loss goes to 300K. Some 4K, it goes to 300K, and then it goes to 8,000K, okay? If what I'm saying is clear to you, type super clear SC in the chat box. Or you can also, on a scale of 1 to 10, please give me a 9 or 10 if you can relate to what I'm saying, because this is the first thing I want you to identify the sigma level and its effect on the total cost in the example what we had given. And you can also see this effect on the error rates or the defects rates. So every reduction in the variation, every sigma level reduction in the variation is increase in the reduction in the variation and increase in the sigma level is so important. All right, so having said this, let me quickly show you this variation. So Sheward is called as the father of control charts, okay? And you can see the two red lines, okay? All of you type CL in the chat box. These are called control limits. We'll talk about control limits in the control section, but I want you to understand that variation is inherent in any process. And those processes which are under statistical control, they will show the variation within this red band. So our objective here is to make sure that you create a stable process. Okay. And after you create a stable process, you enhance the capability and create a capable process. Okay. Right. So if you're able to see my screen, if you are able to see the chart, type I see as I can see in the chat box. Okay. So there are a lot of people who can see that. Okay, fine. Great. Just wanted to make sure you're seeing the right screen. Okay. Fantastic. Now, who is this gentleman? Okay, many of you might know him, right? Who is this gentleman? Deming Chase Srikant Murthy, fantastic. Berang, that's Deming, correct. Ved Prakash, that's Deming, all the way. Thank you very much. Yes, you're right. Okay, during the same period, Edward Deming was working with the US Department of Agriculture. He's a physicist, mathematician. I'll not read too much of his history but we have to give due regards to all our quality gurus, and that's why I'm showing here. So actually, Deming came to Japan and helped them because Japan was bombed by America, and Americans felt guilty probably, okay, and hence they said, now we will revive the economy of Japan, and quality gurus like Deming and Juran went to Japan and revived the industries by teaching them the quality methodologies. Now, one of the Deming things called as PDCA. All of it are PDCA, quite common. We all know plan, do, check, act. Whatever that we try to do, we need to first plan it, then we need to execute as per plan, then you need to verify, evaluate, right? Verify or evaluate whether it is done as per plan, and then the act of standardization. Okay, so that which is sort of sustain, right? You standardize and sustain so that you don't slip back. Then you follow SDCA. All of you type SDCA. After you plan and things are standardized, okay, you follow SDCA. SDCA means follow the standards, do as per standards. Okay, you have standards, do as per standards, make the standards clear and do as per standards, and verify whether you're following as per standards, and then adjust if required. Adjust the standard if required. All right. So far, if you found this interesting, useful, valuable, fantastic, awesome, please put in the chat box, give me a dose of dopamine so that I also get excited, energized, feel motivated from your remarks, and proceed with the session today. Thank you, Surya Narayan. Thank you, Dinesh. Thank you, Radhakrishnan. Thank you, Pradyo. Thank you, Naveen, Barang. Okay, Gunashekar. Thank you, each and every one of you. I really value each and every one of your comment. Okay, the fact that PDCA is a cycle means it never ends, because improvements have to be continuous, and Six Sigma is really following this cycle. DMAC methodology is also a part of PDCA because define, measure, analyze is all planning, improvement is doing, and control is actually check and act. Okay. Thank you very much, Uma Shankar. Thank you, each and every one of you. I'm not able to read out names because so many people are there saying it's valuable. So I want to bow down before all of you and thank you, because you are my encouragement. You are my motivation. Okay. Thank you, Srinivas Rao, for that lovely symbol. Okay. I want you to help industries. If you help industries grow, your career also flourishes. Okay. Okay, so the following World War II, Deming worked on Japan on behalf of United States government. So, and then there was this Ishikawa. We know this is, fishbone diagram, right? Ishikawa diagram, fishbone diagram, cause and effect diagram, and all that. Okay, so I've already explained to you. And Deming, what he did was he did something which was fantastic. That is, he gave a very structure to this quality model. And he asked Japanese to follow the structure. And he also said, if you follow this structure and follow all the standards I laid down by the model, they established something called as Deming Prize Committee. Okay. And so if you see, even today, people apply for this Deming Award, and there are a lot of people creating Deming Award. Okay. Who had applied and got the Deming Award. All right. Question is, who is considered to be a father of control charts? Father of control charts. I think nobody should miss to answer this question, okay? I've been shouting. All right, father of control charts. Yes, C is the right answer. It's Walter Stewart, okay? Just because I showed Deming, you should not put, somebody's putting denim also. Right, interesting. Thank you very much for your active participation. And this gentleman is Walter Stewart. Okay. Continuous process improvement, Toyota and lean. Okay, let's quickly look at this. Okay, big part was played by Toyota Production System. All of you type TPS in the chat box, okay? All of you type TPS in the chat box. And I wanted you to recommend something very, very important, okay? And, I wanted to share with you that there is a book called Toyota Wayfield book, okay? This was my first book that I used in my consulting career, okay? This book is pretty old. In fact, you would see that I've scribbled each and every line in this book, okay? There are a lot of scribbling that I would have done in this book. I don't know how many of you can see this, okay? And a lot of notes that I've taken from in this book. And I can share this book inside our community, okay? And for those people who join this world's largest community of lean champions, I can definitely share the copy of this book. Okay, now, so this is Toyota Production System is one of the great systems which laid down what we call as lean today, right? So you see Mr. Deming, he applied Deming's, Toyota succeeded. Actually, Toyota succeeded by applying Deming's teaching after the devastating war, right? So now Toyota also used ideas from Henry Ford. Okay, there are a lot of ideas. The entire mass production, the batch production, actually the batch production was converted to single piece flow by Toyota. Multiple parts, assemblies, and all that. Okay, there are a lot of ideas that Ford did. There's a book. The name I'll share, and there is a clear explanation on how the Ford principles were adopted by Toyota in the initial eras. Okay, so the question is, the guru who helped Japan in the quality movement is, okay, I know this question is obvious, right? Because I just shared now. So yes, Edward Deming, thank you very much. Just now, because we discussed that. All right. Now, and this is gentleman Edward Deming. Now let's see. There is a gentleman called Kichiro Toyoda. He was a Japanese businessman, and he is the son of Toyota loom worker founder, which is Sakiji Toyoda. His decision to change Toyota's focus from automatic loom manufacturer to automobile manufacturing created Japan on what we know as Toyota Motor Corporation today. He had experience working in factories, but basically he was from textiles, and he brought some of these ideas, particularly Jidoka is one of the concepts we'll talk later, from the textile looms to really Toyota production system. Okay, and there is one more gentleman whom you should remember is Toyoda, E.G. Toyoda and Taiichi Ono. They introduced a concept called JIT. Okay, all of you type JIT in the chat box, just in time. Okay, which actually is the foundation for what we call as the lean principle or Toyota production principle. Okay, so if you see stability brings in stability into the system. So two pillars of this so-called Toyota production system is JIT and Jidoka. Okay, JIT and Jidoka. You can also type Jidoka in the chat box. Okay, so which basically starts with the customer and deliver what the customer wants efficiently, eliminate the unnecessary step, and smooth flow of the process, make things simpler. Okay, remove waste from any process, cutting waste out of every process. Awesome. Okay, now what is Jidoka? So if you see here, you are manually feeding and watch the machine cycle. Now you're automatically feeding and watch the machine cycle. When you're automatically feeding, there is something called as a signal. You can call this an and-on. Okay, the and-on light means a colored signal. It can be something like amber, yellow, and green. Okay, red, yellow, and green. The point here is, as soon as a rejected part is fed into the system, there is a signal, and the machine the parts get ejected automatically. Okay, So I mean, if you see the exact definition of this, automation with a human touch, automation. Okay, if you can type the word automation for the benefit of others. Okay, so Jidoka is a way to catch and fix mistakes in the process. So instead of finding errors at the end of making something, Jidoka helps to catch that at the same process steps as soon as a mistake happens. So in this way, people can quickly improve and fix the process. Yeah, beautiful. Okay, all of you have typed the right word. Okay, so to make Jidoka work well, machines are set up to tell the difference between good and bad results. Machine should be able to differentiate between what is good and what is bad, so that the machine can stop and then you can fix that. So when you know people it's going something wrong, then it helps people to fix it immediately. Now let's take a look at this quality gurus. Okay, there are a lot of quality gurus. So all of you put pranams to all these quality gurus. Okay, how do you put fold, hand fold, right? Hand. How do you bring that symbol? Hand or namaste? No, I don't know. I'm not able to pull out that emoji where you fold your hands and put right. I'm not. If somebody can put that, please put. Try to find out quickly. I was not able to find out. Search and find out. Anyway, just put pranams to all these quality gurus. Yes, yes, yes. Wow. Okay. Right, right. Great. Because these are the people responsible for all of us sitting here and doing it, right? Pay our salutations to them, right? Good. All right. Now, you find somebody here. Who is this gentleman? Let's see in the chat box. Who is that? Yes, that's Juran. Okay. So Joseph Juran, Edward Deming. So the right answer is Joseph Juran. Fantastic. Okay, sorry. Okay. Now let's see some quickly. Let's check. Who is this gentleman? Hi, who is this gentleman? Anyone? Do you want options? Yes, that's Taichi Ono. Congratulations, all of you. Congratulations. Okay, let's look at some other person, right? Who is this gentleman? I think you know by this time this guy's name is familiar, right? Yes, WS. People are typing short form now. Walter Sheward. Excellent, 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 excellent. Fantastic. Thank you very much. We've got an awesome team today, yeah? All right. So let's see. Okay, this is an obvious one, I think. All of you type his name, right? He needs no introduction. Even before I put the options, people are typing Edward Deming. Fantastic. All right. Thank you very much. And let's see. Motorola's focus on defects. Now, what I'll do is I'll just logically stop here. Okay. And if you found today's session interesting, useful, fantastic, awesome, just put it in the chat box.